Good evening, everybody. My name is Julie Mary Gracia, and today we'll be looking at some applications of modern concrete tests. Testing is actually done with a tamping rod, this object, and layer by layer, we add more concrete, and then when we get to the top, after evenly distributing each layer, we clean it off. And when it's flat, we lift it up and compare the slump cone to our slump of concrete. That's our true slump, and this should be given 3 to 5 inches. Discrepancies are caused by misproportions in our concrete. Like if it's too dry, it's not flexible. Or if it's too wet, it's too flexible. And when it's not proportional at all and we don't have correct ratios of our concrete, whether it's too much cement, too much water, and it just slumps down. Water absorption tests are done after curing or being fully solidified. Now, when it comes to the placement of our submerged samples, they're supposed to be in a sealed container and supported so that we have full coverage of our sample getting in contact with this water. An example of this water absorption test can be found in a PDF file. I've linked down in the description box or in the bibliography later towards the end. But in that PDF, they do a water absorption percentage, and it's done by dry weight minus the wet weight, which we get after testing, divided by the wet weight times 100%. And that gives us our overall percentage. Compressive strength tests need to be done with certain requirements, like in statics or calculus, especially when you're deriving in respect to time of megapascals or psi. Now, this estimated cylindrical shape is what used to be a concrete sample, and it's done this way to replicate real life results of what would happen to that concrete. Modern concrete tests are to be done with precision, especially through the engineering process, because if you make a mistake, you gotta go back and fix it and revise. This is my bibliography. Thank you so much for your time.